Example 2. 2 light bulbs are selected at random from a lot of 24, of which 4 are defective. What is the probability that A, both of the light bulbs are defective, and B, at least one of the light bulbs is defective? Kind of an unrealistic circumstance, because usually if you're doing quality control, you really don't know how many are defective out of a lot, you know. But here we do are in we at least we're given that we have a lot size of 24, 4 are defective, which means we have 24 light bulbs. 4 of them are defective, which means 20 of them are working. So with that information, these calculations are a little bit easier to do. We know we're picking 2 light bulbs. I also see this at least 1 at the bottom there, which means, you know, that can sometimes be a little bit on the complicated side. Because that means 1 or more. And, you know, there's different ways of me handling it. So for me to answer both these questions, it might be a good idea for me to set up a probability distribution table, where I'm going to let X be the number of defective bulbs. And really, because of the way it's described here, 0, 1, and 2 are my only possible outcomes. I can either have 0 defective light bulbs, 1 defective light bulb, or 2 defective light bulbs, because I'm only picking 2. I'm going to work out these probabilities. The probability that none are defective means I have basically the number of outcomes where all of them are working, or both of them are working, over the sample space number. The sample space number is me picking 2 bulbs from a group of 24. So the combination where n is 24 and r is 2 is going to be the denominator for all of these. If I have 2 of them that are working, then I'm looking for a combination where I'm picking 2 from the 20 that are working. And that's going to give me my numerator number, and this probability ends up being 0.6884. If I have 1 working and 1 defect, then basically I'm going to have the combination of n being 20 and r being 1 to represent the working light bulbs numbers, or number of outcomes, and I'm going to have C of 4, 1 represent the number of outcomes for choosing 1 from the defective group. If I multiply those together and divide by the C, where n is 24 and r is 2, I get 0.2899. And for 2, I'm still calculating in a very similar way, but I'm going to be able to do something to check to make sure that I'm more than likely right in a moment. So I'm going to look for a number of outcomes where there's 2 defects over the total number of all possible outcomes. Again, the number of all possible outcomes is C, where the combination where n is 24 and r is 2. To have 2 defects, it means I'm picking 2 from the group of 4, and I'm looking for the number of combinations for that. And when I divide them, I get 0.0217. One of the things I could do to check that these calculations were right is make sure they do total 1, and they do. So these seem to be on the right track. So when I look at the first one here, what's the probability of both light bulbs being defective? Well, that's the probability that x equals 2, so that was worked out when I made the table itself. The probability of at least 1, well, I could add up the probabilities of 1 and 2, add them together, and get 0.3116. One of the things we're going to make use of, and you're going to see me use it momentarily, is that I could have also calculated by saying, well, the probability of being 1 or more is 1 minus the probability of having none.